And 10 is going to be talking about composite figures. And basically what composite figures are they're different types of figures that are made up of more than one two-dimensional shape. And let me show you, we're going to do this all by example. So we're going to say find the area of the given shape. Okay, and these are going to be somewhat irregular. So let's look at the first one. We're going to have a nice little triangle piece here and a rather long rectangle piece here. Okay, this is going to give us a measurement of 16 centimeters, and we are going to have a 10 centimeter measurement on this longer side. Going to have a 9 centimeter measurement here and a 4 centimeter measurement there. Okay, so the first thing we're going to do is we're going to divide this figure into parts. So we're going to divide this figure into a triangle and a rectangle. And I'm going to do that by using a dotted line to show you where I would be dividing those up. So I'm going to just go here, and that is going to be the triangle on the top and the rectangle on the bottom. Okay, next we're going to find the area of each of these pieces. So for 2, we're going to find the areas. Okay, the area of the triangle is 1/2 the base times the height. Well, the base of the triangle, that's a little bit like, right? We have 16 here, and from this point on is 9. So if we take 16 and we subtract 9, we're going to get 7 centimeters. So that tells us that the base here is going to be 7 centimeters. Okay, and then the height of the triangle is this little piece right here. We know the whole thing is 10, and this little chunk right here that's on this line is 4. So that would mean this part is 4, which would leave this part to be 6 centimeters. Okay, so then let's use those figures to calculate the area of the triangle. That's going to be 1/2 the base, which we now know is 7, times the height, which we now know is 6, which is going to equal 21 centimeters squared when we get it all in there. Okay, so we do all the calculations. Then we're going to find the area of the rectangle, and remember that's just base times height. When we look here, we have a base of 16 and a height of 4. We're going to multiply those together, and we are going to get 64 centimeters squared. And then the last thing that we're going to do is we're going to add them together. And so you can see this is how we would add them. 21 plus 64 from the 2 that we just solved here is equal to 85 centimeters squared. And that would be the answer for that one. Okay, so again, this is doing our composite figures, and I'm going to slide back up to the top because I'm going to add a little thing that we probably should have already added. We're going to say find area by adding, because we're going to do both of these examples by adding. Okay, so I'm going to need to flip the page. I'm going to slide back down for a few minutes. If you need to pause, go ahead and pause. Otherwise, I'm going to move on to another example of composite figures. So here's another example, continuing on item number 10, another example of composite figures. But this time we're dealing with a circle. So we're going to have a circle, and we're going to assume that's a perfect circle that has this here, and then a nice slant over here, and then it's connected here. Okay, so the first thing we're going to do is we're going to divide the figure. And I will tell you the given measurements. So this said that this has a circle center here, and this already had, circle center here, I guess, and it had a radius of this measurement was 9 inches. This horizontal or vertical measurement here. This one was 5 inches, and the bottom here was 12 inches. So this is going to be a semicircle and a trapezoid, right? So we're going to find the area and the area of the semicircle and the area of the trapezoid. So a semicircle in this case was 1/2 of the circle. So the area of the semicircle, we'll just make like a semicircle, right, is 1/2, because it's a half of a circle, times the area of a circle, which is pi r squared, which will leave us with 1/2 times pi times, oh well, we only have a diameter here of 9. If we divide that diameter in half, we're going to get 4.5 inches to be the radius of this circle. So we're going to have 3.14 times 4.5 squared, which is the same as saying 4.5 times 4.5. So then that will be equal to 1/2 times, let's use 3.14 for pi, times 20.25, which is 4.5 times 4.5, or 4.5 squared. And when you use your calculator and you multiply all of that out, you're going to get 31.8 inches squared. Squared because it is area. Then you are going to do the area of the trapezoid. I'm just going to call that T. The area of the trapezoid, or T, is 1/2 the height times the base 1 plus the second base. So that's going to be 1/2 times 9, which is the height of the trapezoid, times this base 5 plus this base 12. 5 plus 12. Okay, and so then we're going to continue to work that through. If we work that out some more, we have 1/2 times 9 times 17, and that's going to be equal to 76.5 inches squared. And then for the third step, we're just going to add those together, 31.8 plus 76.5, and that is going to equal 108.3 inches squared. Okay, so that just moves us through that one. And then this next portion is going to be talking about doing this same kind of thing, except for this time we're going to be finding the area by subtraction. Find area by subtraction. Okay, and I have about a half page of paper left, a little bit less, and I think we can fit that into this last one. Okay, so we're going to have a figure that, in this case, it's going to be a rather large rectangle, but within that rectangle there's going to be a little chunk taken out of it. Okay, this up here is going to be a 14 meters. This will be 6 meters. This section here is 6 meters. Also on this side we have 3 meters. The height of this triangle is 4 meters. And that is the measurements we're given. So we're going to need to find the area of the rectangle. The area of the rectangle is the base times the height, or 14 times 6. And that is going to give us 84 meters squared. Okay, and then we're going to use the area of the triangle, which is 1/2 the base times the height. Okay, well, we don't know the base really, but we can figure it out. This is 14 up here, and these two are 6 and 9, or 6 and 3, together 9. So what's left over for this little chunk would just be 5 meters. So we're going to multiply 1/2 the base of the triangle, which we know is 5, times the height of the triangle, which we know now is 4, and we're going to get 10, and we're going to write meters squared on the bottom because I'm out of room a little bit. Okay, so now we're going to take the area of the rectangle, which was 84 meters squared, and we're going to subtract out this little chunk that's missing from that triangle, which was 10 meters squared, and we're going to get 74 meters squared. Okay, and that's the two ways of doing composite figures, taking what we know and either adding or subtracting based on what we we're looking at, right? So we're going to go ahead and you're going to log on to, I want you to watch a video for example 3. at my.hrw.com. And then when you're done with that, you're going to look at, this is section 9.5 in your math book. And we're going to do all of them. So this will be homework. Is going to be 9.5 all, and there's only 8 problems. I think you guys can do that. So if you watch this video, it'll give you a little real world example, and then you're going to do the homework. Okay, if you have any questions, feel free to ask. Otherwise, have fun on your homework.